Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss about statistics mainly for machine learning scientists. So, before going on towards the statistics, of course, we want to discuss something related to data. So, data, exactly dear friends, actually it plays a significant role in the field of data science. Raw data is put into enormous experiments to generate meaningful insights that drive many business goals. Understanding different types in statistics will take you one step closer to picking the data type that matches your business requirement. So the data type knowledge will help you accurately apply statistical measurement to raw data and conclude meaningful insight. So you must be able to identify the data type you are working with. So if you want to select the apt visualization model, of course you have to know what is the type of data you are using. And of course, dear friends, here there are two types of different data, that is categorical data and quantitative, which we just say numerical data. This categorical data represents characteristics. So it is also called qualitative data. So which means you cannot express it as a numerical value. Therefore, you cannot measure it. It involves variables such as words or symbols or pictures. So which helps you short information based on the category. So for an example, holiday destination or gender or language like that. And this exact category, it is further categorized as like binary, nominal and ordinal. And dear friends, if you have only two such further categories, it is specified as like binary categories. And coming to this nominal type, this nominal type of data involves variables that do not have any natural ordinary. It is also known as nominal scale and derives its origin from a Latin word normalis. So which means pertains to name. So it helps you in labeling variables without providing the numerical value. Okay. So you cannot order or measure nominal data sets. Furthermore, you can't perform any arithmetical operations on these nominal variables like addition or subtractions or division or multiplications, etc. But how this exact nominal values would be? Of course, kindly just note it, dear friends. For the few examples, I just let you know, like colors of a person's has. Of course, like black or brown or burgundy like that. So this cannot be compared with one another to derive any meaningful information about it. So the same thing as like gender in another variable. It is impossible to order the gender category in the rank wise. And to the same, marital status is also another nominal variable. It is not possible to rank the marital status of a person as better than the other like that. So you can examine the nominal data using the grouping method. So you can group similar data into one category and then calculate the percentage or frequency of the relative data. Coming to this ordinal. So here ordinal means something that is in order. So the ordered type or ordinal type of data involves variables that follows a natural order. So ordinal variables are placed in order by their position. For an example, first or second or third like that. Or as the ordinal variables only represents a sequence, you cannot perform any arithmetic operations on these variables like addition, subtractions to the same as like divisions or multiplication. But it is primarily found in surveys or questionnaires, financials, etc. And let me just give some examples also. See here, dear friends, when I'm coming towards ordinal, you can just specify as like class ranking in a school or time of the data as like morning or afternoon or evening, and ranking of athletes as like first or second or third. Like that here, you can examine the ordinal data using numerous visualization tool and express the information using tables in which each row shows an unique category. Next, we are just coming towards this quantitative. Of course, dear friends, quantitative is otherwise called the numerical data. Yes, it is one of the simplest data type to understand. As the name says, yeah, it represents a numerical value and help answer question as like how many, or how much, or how long. So for an example, we can just say the number of apples or number of students in a class, or what is the height or weight of a person. So it attempts to quantify the items. It attempts to quantify the items means by measuring numerical variables that makes them count in nature. So the key here is that a numerical variable can take an infinite number of values. And yeah, it is further divided into discrete data and continuous data. And here this discrete data type, yeah, it involves only integer or discrete values. It contains a finite number of values that cannot be subdivided into smaller parts. So it takes into account only those items that you cannot measure but only the count. So for an example, number of boards on a board or number of employees in an organization. So that you can use a bar chart to display this discrete type of data. Okay, so one among the things. I'm coming towards this continuous. Dear friends, actually on the other hand, a continuous type of data is the data that you can measure. So it contains an infinite number of values that can be subdivided into smaller parts. Okay, so it takes into account only those items that you cannot count but only measure. So it can take any values between like something as like 40 to 50 or 1 to 100. So like that. So even though you can just say what is the length of the pages of a book or what is the time taken by athletes to finish a race or the weight of the student in a class. So these things comes whether the exact data is quantity related or not. So yeah, under kindly just have a note, dear friends. You have seen different types of data used in statistics and how it is categorized into different categories. And of course, dear friends, you also acquired an understanding of difference between this discrete and continuous, I think. So yeah, you are going to use it in statistics. So where this exact statistics comes? Of course, when we just take this exact data from the population. See, in general, the size of the data that is to be processed today is quite large. So this leads you to the questions where you would use the entire data or some representation, some representative as like sample of the data. So in several data science techniques, sample data is used to develop an exploratory model also. So thus, even in the data science, sample is one of the way which can enhance the speed of exploratory data analysis. So here the population is in this case maybe entire set of the data that you may be interested, and here what is the sample? Of course it is the subset of the population. And yeah, with the sample, how you are just going to fetch the sample? Yes, of course, by using some probability, you are going to fetch the sample from the population. And here, what are all the functionality you apply in the sample? Yeah, that is what the descriptive statistics. Yes, dear friends, actually today we are just going to discuss about the descriptive statistics and what you are applying onto this sample and what is the exact result, and when you compare the exact result with the population, yes, that is what specified as like inferential statistics. So today let me just discuss on to the descriptive, and the next session let me just make it on towards the inferential with the probability. Okay, and coming towards this descriptive, of course dear friends, this descriptive statistics are number that are used to describe the summarize the data. So they are are used to describe the basic feature of the data under consideration. They provide simple summary measures which gives an overview of the data. So summary measures that are commonly used to describe a data set or measures of central tendency and measures of variability or dispersion. So say there are so many things are there, dear friend. So let me just come one by one. Before that, let we make use of a data set here, and yeah, here we are making use of a data set which is a Fortune 500 data set. Of course, it is a older, but let me just have it as like a sample. Okay, from that sample only we are just going to make use of it. Yeah, before, yes, of course, this exact data set contains a revenue and profit figure of this Fortune 500 companies along with their ranks. And yeah, this is of course a older data, but anyhow, let me just see what is the statistical basic things, and from that how we are just going to discuss about this measures of dispersion or measures of central tendency, which is comes under this descriptive statistics. Okay, going on towards that, yeah, kindly just let me include the necessary libraries, and yeah, dear friends, here we are making use of the pandas numpy to handle the exact data set, and to have a visualization, yeah, we are just going to have use of this visualization tool library, that is Matplotlib and Seaborn, and to avoid some warnings, let me just make use of this ignore warnings. Okay, now what's that? Yeah, we are just going to load the data, and of course what we are having it is Fortune 500. Yeah, of course it is in 2019 data. Okay, so let me just have use of it, and just diving on to explore what is there in the data. So with that we are just going to make some analysis, and kindly just observe, dear friends, before going on to that, what is the exact size of the data we want to know. So that is dimension of the data. So with the exact function shape, yeah, we can see that it has 500 records with 4 columns. That is 500 instance with 4 variables. Okay, and yeah, even you can just have a view of that by providing the exact function head, and where this head, it just shows the top 5 records, and here we are having, and of course as I have already specified, the 4 variables, that is the 4 columns, the 4 futures. Yeah, what are all the things are, yeah, it's all about rank, company, revenue, that is in dollar millions, and towards the same profit, that is also in dollar millions. Coming on towards the summary, dear friends. So here, let me just have an info, that is info, it is in the sense, yeah, what is the data structure it has, the structure of its data set. So see here, dear friends, we are having 500 entries. So how the indexing range it would be? Yeah, it is from 0 to 499. Okay, and we are having 4 columns. Each and everything here it is specified is as not null, so no missing data is there. And coming towards its type, yes, dear friends, this rank we are having it in integer. Where come the company? Yeah, of course it is in the name as like, so it is an object data type, and the last 2, the revenue and the profit, that are in float, and of course it is of 64-bit. So it is already specified. So before going on to the data, you kindly just have a look on which we just have it here. Now, although we just have seen that they are not null, but sometimes even 0 would be a value, or sometimes even it would be misspelled as like 0. So let me just check whether any missing values is there or not. So in such a case, let we make use of is null functionality, and if it's so, how many? So for that sum of, so here let me just have, and of course dear friends, we don't have any null, that is we don't have any missing value. Okay, moving on to the descriptive statistics. Dear friend, here we are just going to dive on to main important function, that is describe. So this exact describe, so to which we want to describe. Of course, we want to describe about the data frame which we have just specified, and of course where it is, yeah, from the data that is loaded. So we are just naming it with that df. Okay, so that one we want to describe. Okay, so when on just providing that describe, so kindly I execute it. So have a note of it, dear friends. What are all the things we are just getting is, yeah, a summary, just a summarization of the whole the data. And this exact functions, dear friends, you can also include all, which just gives a statistical thing of objects. And if it is not on a defaultly, it just gives a summarization of a numerical data only. Okay, so if you want to just give us like all, yeah, it includes both the numerical and the character columns. Okay, but here we just have only the numerical functionalities, and hope I just include that. Yeah, see here you can also specify only the object. Only the object is in the sense, yeah, you just have only about the company. Okay, and I just to show you. So here the topmost is Walmart, and which it just has a 500, and yeah, its frequency is 1. So this is what the exact count. So of course here it is not exactly correct, because the count here it just specify as 500, and which is specifying as like a maximum, but it is not correct, because each and every company, yeah, it shows a single occurrence. Okay, so here only with the object, when we just make it a summarization that is describing towards the object type, yeah, exactly, it is not effective onto this data set. Okay, yes, moving on, if you want everything to be included, that is, if you want to add the variables as like include all, yeah, dear friends, you just get everything, and kindly have a note of it. If you are having an only the describe, yeah, you just get the count, mean, standard deviation, minimum, maximum, and this 25%, 50% and 75%. And towards, when you just have a look on towards this object, kindly just observe, dear friend, you can just get the count and how many times that is towards the uniqueness, top of the exact objectives, and what is the frequency of occurrence. And here it is very much important that we just have a look on to the describe of all. So here we are able to get the exact data of the company too, that is also included, but kindly just observe, we are not able to have the exact data related to the numerical things that is combined listed under this object. So as like mean or standard deviation or minimum or maximum, of course here we are not able to, but rather than that towards the top and frequency, in the other functionalities as like unique, top, frequency, under rank or revenue or profit, we are not able to summarize that. Okay, now moving on to the computation of measures of central tendency. Dear friends, this exact one, what it is, central tendency, that is means a central value which describes the probability distribution. It may also be called a center or a location of a distribution. So the most common measure of the central tendency are mean, median and mode. And the most common measure of central tendency is the mean. And yeah, if you are having, see, actually, of course, we are just going to see about the distribution. And if anything skewed distribution or whether there is any concern about the outliers, yeah, the median may be preferred. So median is also more a robust measure than the mean. Okay, let me just discuss one by one. And coming towards this mean data, mean about the statistic, dear friends, actually, as I have already specified, the most common measure of central tendency is mean, and mean is also known as the simple average. Okay, and here it is denoted by a Greek letter as like mu, and for the population, and here x bar for the sample. And we can find mean of the number of the element by adding all the elements in a data set and then dividing by the number of element in the data set. So it is the most common measure of standard tendency, but it has a drawbacks also. That is, actually the mean is affected by the presence of outliers. So mean alone is not enough for making this business decision. Okay, now let me just have a look on to know what is the revenue, that is under dollar millions, what is the revenue, average revenue about this data set. And for that, of course, I'm just going to call with this data frame with a revenue, with this column revenue dollar million. And let me just have a view. Kindly just observe, dear friends. We are just getting here, it is $27,442 million. Coming towards this median. Yes, dear friends, median is the number which divides the data set into two equal halves. That is, to calculate the median, we have to arrange our data set of n number in ascending order. That is the firstmost thing. Okay, and the median of the data set is that the number, whether we are just going to make it towards the position, that is n plus 1 by 2, the position if it is odd, and of course if n is even, then the median is the average as like n by 2 we have to specify, because the n by 2th number, that is n plus 2 divided by 2. So that is the number. And of course, dear friends, median is robust to outliers. So for skewed distribution, or whether or when there is concern about the outliers, the median may be preferred. Okay, and let me just know what is the exact median of this current particular data. So for that, let me just call the median function here, and I just execute, and let me know it is 12,889. And dear friends, kindly just observe this. You are able to have this exact data. Okay, you are able to have this exact data under this standard that is described itself, that is mean or standard deviation. And of course here you can just get the mean value, which we have done it, and the 50%, that is what the median, it is 12,889, and here we just go here to 12,889. Okay, now coming towards the mode, dear friends, kindly just have a note of this. See, mode of a data set is the value that occurs most often in the data set. So mode is the value that has the highest frequency of occurrence in the data set, and of course here we are not able to have the frequency with the objective, with the object data type as like company or Walmart. Okay, it is not the correct one. So there is no best measure that gives the complete picture. So these measures of central tendency as like mean or median or mode should be used together to represent the full picture. And let me just have the mode of this particular, and kindly observe. Let me just observe. Here it just shows 14,950. One thing, dear friends, with this value, what are all the value? I just scroll again. Mode is 14,900, and median it is 12,880, and mean value it is 27,442. And kindly just observe how this exact data, whether it is mean is higher or median towards the mode. Okay, so it just shows whether the exact data is normally distributed or any skewness is there. And as with this number which we just have, of course mean is the highest, which is 27,442. Next there comes the exact mode value, and to the last we just have towards the median. Okay, and dear friends, so with this it is obviously specified, there is some skewness. And next, let me just move on towards the computation of measures of dispersion or variability. See, dispersion is an indicator of how far away from the center. That is, we can find the data value. The most common measures of this dispersions are variance, standard deviation and interquartile. And this interquartile range that is exactly which we just shortly specify as like IQR. Okay, so the variance is the standard measure of spread, and here the standard deviation is the square root of the variance, and the variance and the standard deviation are two useful measure of this spread. The spread is the data, how it is spread. Okay, so let me just have, before going on to the functionality, let me just have what is the minimum value, what is the maximum value, and how far the exact range it is there. And dear friends, this can be of course already listed in the describe functionality. So kindly just have a note. So see here, of course we are now currently just discussing about this revenue. So what is the minimum? 5,575. What is the maximum? It is 5,14,405. So let me just have a view. What is the maximum and the minimum? And let me just move on towards the range. So first of all, minimum. Yeah, we just receive it 5,575. And coming towards the maximum, yeah, it is 5,14,405. And with this maximum and the minimum, yeah, if you just find the difference between the maximum and minimum, yeah, that is the range, and which we just have the difference between the both is 5,08,829. And next comes the variance. Dear friends, of course, variance measures the dispersion of a set of data points around their mean value. So it is the mean of the squares of the individual deviation, and here variance gives results in the original unit that is squared. So let me just have the variance. Wow, it is a huge number. Okay, so we are having a variance with a huge data is there. And of course, everything, whatever we just see here, yeah, we are just going to summarize towards the last. See, the described, already we have described about the measure of central tendency. Yeah, we are currently on to the dispersion, and the next dispersion, it is all about standard deviation. So dear friends, when coming towards the standard deviation, yeah, it is the most common used measure of variability, and it is the square root of the variance. So when already we have the variance, and the square root of this variance, it is what the standard deviation. And yeah, for normal distribution data, approximately 95% of the value within those actually standard deviation of the mean. And of course, dear friends, standard deviation gives result in the original unit. And yeah, of course, let me just have the standard deviation of revenue. Yeah, we just get 43,936. And next here we just come with the 50th percentage. Dear friend, this exact 50th percentage, what it just gives is, yeah, when we just make use of the percentile, can we just observe, dear friend, this one we can just check with this. Okay, so this is what the 50th percentile and 25th percentile and 75th percentile. And for your information, this exact 25th percentile, it is specified as like Q1, and whereas the 75th percentile, it is specified as like Q3. And what is the between mid of that? That is the 15th percentile, that is already specified as like Q2. So let me just have the exact value of Q2, Q3 and Q1. So which would be used to identify or calculate this interquartile range. So what we have in the median, so it is 12,889. Of course, we have already seen this by using the mean function. And next we just go with the 75th percentile. So it is 24,130, and 25th percentile it is 8,117. And again I just specify, dear friends, this exact interquartile range, yeah, the exact third measure of this spread is what the interquartile range, so shortly specified as like IQR, and it is calculated using the boundaries of data that is situated between the first and the third quartile. The first and the third quartile, of course, here it is already specified as like IQR is equal to Q3 minus Q1. And in the same way that the median is more robust than the mean, and here the IQR is the more robust measure of the spread than variance and the standard deviation, and should therefore be preferred for small or asymmetrical distribution. So it is a robust measure of spread also. So yeah, for identifying the IQR, so here we just go with the exact calculation, and yeah, you can also have a view of this exact quartile and towards the percentile. Yeah, it is easily observed by using box plot. And let me just have a view of a box plot. Of course, there are so many outliers are there. Okay, so here, of course, dear friends, we are discussing about the concept and non to the data or data set. Okay, so let me just have a learning as like, yeah, there are some outliers in this function or in this data set, and yeah, we are just going to move on to the next topic. It is all about measure of shape of distribution. See, dear friends, we will look at exact measure of shape of distribution. See, there are two statistical measures that can tell us the shape of distribution, that is skewness and kurtosis. Okay, so these measures can be used to convey information about the shape of the distribution of the data set. And here, when coming towards this skewness, dear friends, of course, skewness is a measure of the distribution's symmetry or more previously lack of symmetry. It is used to mean the absence of the symmetry from the mean of the data set. And it is a characteristics of deviation from the mean, and yeah, of course, dear friend, it is used to indicate the shape of the distribution of the data. And we have already seen one particular thing, that of course, one such a thing which when we just have this particular, that is mean or median or mode, of course we are going to have a positive skewness. Okay, so that we have already identified. And for your information, dear friends, negative value of skewness indicates negative skewness. Okay, so negative value for skewness, that indicates the negative skewness, and here in this case the data are skewed or tailed, that is, let me just have to check whether it is rightly skewed or leftly skewed. And yeah, by skewing, yeah, if we just having towards that the left tail is long related to the right tail, so that is also we have to see, and the data values may extend further to the left or right or concern to that of right and left. So there is a long tail and the distortion is caused by extremely small values which put the mean downward, so it is less than the median. But here whether what we just get, of course, when we just combine towards the mean, median and towards the mode, yeah, it is specified that we are going to have a skewness. Of course, it is a positive skewness. Okay, so let me just have a view of it. Yeah, we are getting it the value more than 1, so which here it is specified as like 5. And dear friends, we are having 3 types of skewness is that is negative skewness, no skew, and positive skew. And of course, if we have the mean less than median, that is less than mode, yeah, it is specified as like negative skew. And yeah, if we are having the mean or median and mode are equal, yeah, then it is specified as like 0 skew. And in the last one, of course, dear friend, here mean is greater than median, which is also greater than mode. And of course, dear friends, this exact thing is specified as like positive direction, that is positively skewed. And towards that reference of that skewness, yeah, dear friends, kindly just observe 2 important point. 2 important point I have to specify here. Yes, dear friends, when on just making towards this skewness, I just let you know here. So, yeah, here if the skewness is between minus 0.5 and yes, 0.5, that is positive 5, then the data are fairly symmetric. Okay, and yeah, next, if the skewness is between minus 1 and minus 0.5, or here, of course, I just specify, of course, here, or if it is 0.5 and positive 1, then the data are moderately skewed. Okay, so here it is moderate. And last but not least, if the exact skewness is less than 1, okay, so less than actually less than minus 1 or greater than 1, okay, then here, of course, dear friends, the data are highly skewed. And kindly just let me know what happens now. Yes, we are going to have a little thing just by you viewing the plot. So yes, there is a positive skewness is applied. So we are receiving a skewness. Of course, dear friends, this exact skewness we have already seen. That is, here we are going to have the mean that is greater. I just scroll above. So here we are having the exact value of mean. It is 27,000. Median it is 12,000. And mode it is 14,000. So where we just get an, of course, a positively skewed. Okay, so back to the next shape. Yeah, it is all about kurtosis. And when coming towards this kurtosis, of course, dear friends, kindly just observe this is the exact image. And the kurtosis, it is the degree of peakedness of a distribution. See, dataset with high kurtosis tend to have a distinct peak near the mean and decline rather rapidly and have heavy tails. So, datasets with low kurtosis lead to have a flat top near the mean rather than the sharp peak. So, when coming towards this kurtosis, more thing for you. So, kindly just observe here. When on towards this kurtosis, yeah, it is a normal distribution. Okay, I just specify here if it is a normal distribution, when and where it is. If it is, it has the value as like 3. Okay, and often excess kurtosis presented instead of kurtosis, that is where excess kurtosis is simply that is as like -3 or towards that 3. And dear friends, we are having the other types also. So if it is equal to 3, it is normal kurtosis, and here if the normal kurtosis have exactly, that is x is 0 to 3, yeah, it is meso. Okay, and any distribution with kurtosis exactly, that is excess 0, that is 3, yeah, it is called meso, and a distribution that is less than kurtosis, that is called as like Platley kurtosis. And as compared to a normal distribution, its center peak is lower and broader. Okay, and its tails are shorter and thinner. And last but not least, we have one more, which is leptokurtosis. Of course, dear friends, this exact leptokurtosis is the distribution with the kurtosis, the value greater than 3. And as compared to the normal distribution, its central peak is higher and sharper, and its tail are longer and farther. Okay, so let me just have a value of this kurtosis, and yeah, of course, what we just get is 37. Yeah, of course, it is greater than 3, and so excess that is greater than 0. So what it happens? Yeah, of course, here the exact curve is leptokurtosis. And last but not least, dear friends, kindly just have, so far we have looked at the measure of central tendency of data, which includes, yes, mean, median and mode. And also we have taken a look to the measure of spread of the data, which consists of as like variance, standard deviation, coefficient of variation, minimum and maximum value, and of course inclusion of this interquartile range. We have also discussed about the skewness. We have also discussed about the kurtosis. So yeah, dear friends, these are the exact basic descriptive statistics that you have to know for a machine learning scientist. Hope I think so this would be an informative video for you, dear friends. If it's so, yeah, kindly just put a like, and if you are not subscribed yet, kindly just put a subscription and click onto the bell icon so that you can't miss any of the important videos that are going to be launched in the further videos. Okay, so yeah, see you soon in another video, dear friends, and happy learning.